A connecting rod is suspended from a point 25 mm above the center of the small end and 60-50 mm above its center of gravity. Its mass being 37.5 kg. When permitted to oscillate, the time period was found to be 1.87 seconds. Find the dynamically equivalent system constituted of two masses, one of which is located at the small end center. Okay, what do you understand from this question? It is not the connecting rod is not exactly fixed at the small end center. It is fixed at a point which is 25 mm above the small end center. So if you look into the diagram, you can see this center of gravity to center of the small end bearing I have declared as L1. But what is this H? So this H will come in the oscillation formula, simple pendulum oscillation formula. If you see in the question, you don't have the value of radius of gyration, kg is not given. So for that, I am going to use this H and find out using pendulum formula. Where it is fixed, it is going to oscillate about a point which is at a distance H from the, okay, which is at a, so this point is still 25 mm above this point. The difference is 25, L1 plus 25. So from that point, it is going to oscillate about the, like a pendulum. Okay. So that is why it is given specifically. Now given data, H here means your length of the cord for pendulum. So gravity point is considered to be the pendulum length. So what is L1? L1 is the connecting rod center, small end center, where I am going to place M1, mass M1. So that is 25 mm lesser, 625 millimeter. 37.5 is the entire rigid body mass. Period of oscillation is 1.87 seconds. So if the connecting rod starts oscillating about this point, like this, okay, the connecting rod moves like this, and then to this end, it completes one period of, what is one period of oscillation? Right extreme, left extreme, and then to the center. The time taken for this travel is called as one period of oscillation. This time period of oscillation above a point which is 25 mm above the small end center is given as 1.87 seconds. Okay. So now I am going to find out the dynamically equivalent system, two mass system. That's all. Okay. So first of all, let us find out the radius of gyration. It is not given in the question. Kg. Only then you can equate L1 and L2. Find one of the unknown. Okay. Passing through central of gravity. We know that for a compound pendulum, time period of oscillation, the formula is 2 pi root of kg square plus s square by gh. So in this formula, except kg, everything is known to you. Okay. Time period is 1.87. L1 is 0.62 pi. H is 0.65. Gravity is 9.81. That you already know. So put everything, solve for kg. Okay. So the kg, the answer will be around 0.1425 square. I mean, kg square is 0.1425. Kg is square root of 0.1425, which is 0.377. Okay. So I cannot slow down to give you time for this. Please do this calculation yourself. This PPT will be shared. Last class, I forgot to share the PPT. And not even one of you asked. Okay. So today I will share everything. What on the last class, along with that also I will share today's PPT also. Okay. I don't know what you people are doing. Kg equal to 0.77. It is given that one of the mass is located at the small end center. Let the other mass be located at a distance of L2. So L1 we already know from the diagram. So L2 now I am assuming from the gravity point, the other direction, another mass is kept at the distance of L2. Okay. So we know that for a dynamically equivalent system, L1 L2 equal to kg square. L1 0.625 we already found out. Okay. So L1 L2 is equal to kg square. So L2 equal to kg square by L1, 0.377 square by 0.625. So it comes around 0.228. Okay, L2 is 0.228. Now you know L1, L2. Now we have to find out M1 and M2. The formula is already there. Simple formula substitution. Okay, so M1 equal to M into M is the rigid body, connecting rod mass. Here 37 some kilogram, right? M into L2 by L1 plus L2, 37.5 into 0.228 by 0.625, 0.28, 10 kilogram. Similarly, M2, 0.625 into 37.5. See, I have swapped the numbers. Okay, there's a small, it is not a mistake actually, numerically correct. This M is written here, 37.5. L1 is 0.625. Don't get confused. Denominator 0.625, 0.228. Okay, so the answer comes around 27.5 kilogram. That's it. Now you know two masses, two distances. That is your dynamically equivalent system. Okay. So the problem is over. So M1, M2, L1, L2. This is the two mass system answers. Two masses kept at a distance of L1 and L2 from the center of gravity is going to replicate your connecting rod. So with that, I will wind up this. So there is one more topic, correction coupled torque problem, which I am going to skip and move on to the next topic because of shortage of time, if possible, because it is a relatively less important topic compared in your exam point of view. We'll see that if time permits. Otherwise, material will be provided to you. You have to study that. So now I am going to start the introduction to flywheels.